So guys, in our previous video, we saw that how one can coagulate your colloids. And basically, one of the most important method we also saw over there, that is by the addition of your electrolytes. Alright? So whenever you are adding an electrolyte in an excess amount, basically it will be going to result in a coagulation. But in my previous video, I have also mentioned you an example. Basically, for example, if you are having a negatively salt or a negatively charged colloidal salt and you have been given AlCl3, BaCl2 and that of your NaCl. So these are the three important electrolytes you have been given with. Now the question arises that, please do remember, now the question arises that which one among these three electrolytes will be required in a small amount in order to coagulate overall colloid. Once again I repeat, now the question arises within us that within the given three electrolytes, which of the electrolyte will be required in a smaller amount in order to coagulate the overall colloidal particles in a system. So in order to answer this, a rule was proposed which itself is called as Hardy-Schulze Rule. Hardy-Schulze Rule. So first and foremost thing, let us understand what does this rule states us. So basically, it gives us a statement. What is that statement is? First, very much important statement. So whenever you have been asked to write the statement, you should never make use of your own words, because it is a statement which has been given by a scientist. So you have to use the same words as for your statement. So what is the statement is actually, remember, greater the value or greater the valence of fluctuating ion yes, which has been added to our colloidal system. Remember, the greater is its coagulating power. The greater is its coagulating power. Or in simple words, greater is its power to cause the precipitation. Now the question arises that what is the meaning of this statement? For example, I have been given with a negatively charged salt. What it is? I have been given with a negatively charged salt. Okay, take any one example, whatever we have seen. Now you have been given a task. I have to make these colloidal particles as a precipitate. Of course, one of the method, what do I know is by the addition of the electrolyte, of course I can make it as a precipitate. But the task is not so simple. I have been given with, as I have mentioned earlier, you have been given with three electrolytes: aluminium trichloride, your barium chloride, and that of your sodium chloride. What is the main thing is over here? It is a negatively charged salt. So whatever my fluctuating ion will be there, it should be a positively charged. That should be a common sense for you. Whatever the salt they will be giving, the fluctuating ion should be what? It's oppositely charged. So when I am considering the AlCl3, of course, what will be the cation over here? Of course, the metal, which will be electropositive. But the most important thing is what will be its valency. Alva, yavta estirutte valency here. Of course, here it will be Al plus 3. Whereas when I am coming with respect to Ba plus 2. Whereas in sodium chloride, it will be Na plus. So now just look at our statement of your Hardy-Schulze rule. Yen helutte? Greater the valence of the fluctuating ion, valence and what we have written over here at the top corner of your atoms or the ions. So that is actually the valence of your fluctuating ion. Alva? So greater the valence of the fluctuating ion added, yes, the greater is its coagulating power. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನಾವು ಕಂಪೇರ್ ಮಾಡಿದಾಗ what is happening when you are observing the valence of the flocculating ion of your aluminium, it is having a charge of +3. So therefore, among the three electrolytes, which one will be having the higher coagulating power? One which will be having the greater valence. So in the given example, the greater valence is with respect to your aluminium ion. So therefore, AlCl3 will be having the higher coagulating power. So this is what which is explained by your Hardy-Schulze rule. So if it was the case when I am using a negatively charged salt, but now if I have been given with my positively charged salt, yes, positively charged salt, and I have been given with by what I should be a flocculating ion should be what? Which charge it should be having? Negatively charged. So here I have been given with FeCN6 4-, yes, and that of your phosphate ion PO4 3-, and I have been given with Cl- and that of your SO4 2-. Here also the same tendency follows. Greater the valency of the flocculating ion, greater the valence of the flocculating ion added, greater will be its coagulating power. Here also you should see that which number is the greatest. Of course, in the given scenario or the given examples, your FeCN6 is having 4-. So it will be having the greater power to cause a precipitation of your colloid. So first will be coming your FeCN6 4-, soon after that PO4 3-, then your SO4 2-, and then your Cl-. So how can I write these things? Basically, in the first example, the coagulative power, remember it is having three words. We can say as a coagulative power, or it is also called as a precipitative power, or it is also called as what? Flocculating power, all the words are same. It's to cause precipitation. Okay, so in the first case, if I am writing for my positively charged electrolytes, which will be having first one higher coagulative power, it is for your Al+3, then it will be your Ba+2, and then it will be for your Na+. This was for the first example. For the second example, which will be first, of course, FeCN6 4-, then you will be having your PO4 3-, then you will be having your SO4 2-, and at last you will be having your Cl-. Alva. So guys, here one thing you should remember, it is not something to be by hearted. You have to understand the concept over you. Just to remember, for example, I am just giving why your valency increases, your coagulative power will increase. I have just explained. Remember, if I am taking an example of Al+3, which is having a +3 charge. Yes. If I am taking a colloid, okay, a colloid which is having just a single charge, assume it. So what does it mean? One Al has the capacity to coagulate your 3 colloids. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಏನ್ ಹೇಳ್ತಾ ಉಂಟು? ವೇಲೆನ್ಸಿ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ? The power to coagulate your colloids will be more. ಯಾವ ತರ? If each Al is having +3 means one Al is equivalent to that of your 3 negatively charged colloids. 3 negatively charged colloids. Allow. One Al will be equivalent to that of your 3 negatively charged colloids. So easily they will be coming together. Greater proportion of your colloidal particles get coagulated. Similarly, when I am choosing here my FeCN6 4-, FeCN6 4-, that means what? It is having 4. So that means what? You can coagulate 4 positively charged colloids by taking just 1 mole of your FeCN6 4-. So 1 part of your FeCN6 4- is equivalent to how many colloidal particles? 4 colloidal particles. So this is the concept over here. So ಜಾಸ್ತಿ ವೇಲೆನ್ಸಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ? Coagulative power is more. Remember, I'm using the word as what? coagulative power. And whatever we have written which is greater than Al plus 3 is greater than Ba plus 2 is greater than Na plus, it is all with respect to the coagulative power. Is that clear? But now one important thing, so this was with respect to your exam oriented things. Yes, but I would like to mainly focus on your competitive exams. So basically, whenever we are measuring the coagulative power, it is not the power actually we measure. Instead of that, we measure a value which is called as what? Coagulative value. What do we say it as? Coagulative value. So what is this coagulative value? First let us understand. So basically remember, it is the minimum number. What it is? It is the minimum concentration. It is a minimum concentration of an electrolyte. What it is? It is a minimum concentration of an electrolyte in millimoles per liter. In millimoles per liter. Yes, it is the minimum concentration of an electrolyte in millimoles per liter required to cause a precipitation of a salt. To cause precipitation of a salt. To cause a precipitation of a salt in 2 hours. In 2 hours is called as your coagulative value. Is called as coagulative value. So what is mean by coagulative value? Now let us see. So basically what is it saying? It is the minimum number. Remember, these are the important terms you should remember. So it is the minimum concentration of an electrolyte. Coagulative, what is the value? It is the minimum concentration. So whatever we will be getting the value, it will be the minimum concentration of an electrolyte, which will be in terms of what? Millimoles per liter. That is required to cause the precipitation of a colloidal salt in 2 hours. Is called as a coagulative value. So when we were seeing the Hardy-Schulze rule, there we have noticed that we chosen over there as not as the coagulative power. Instead, we have chosen over there as that of your. So in the Hardy-Schulze rule, we have seen that whenever we were writing the tendency of your flocculating power of the ion of an electrolyte, it was measured with respect to the coagulative power. But do remember, we are not getting the values of the coagulative power. Instead, whatever we will be calculating, it will be a coagulative value. Now the question arises that what is the relationship between your coagulative value and that of your coagulative power? Very much important concept. Okay, you have to understand this because it is the part which will be coming as a question in your competitive exams. Remember, your coagulative value, remember, it is inversely proportional to your coagulative power. So whatever the coagulative value you will be getting, alva, it will be what? Inversely proportional to your coagulative power. That means what? Higher the coagulative power, higher the coagulative value, what will be? Lower will be the coagulative power. But do remember, coagulative is directly measuring your precipitating power. Alva? ಎಷ್ಟು ಬೇಗ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನಾವು ನೋಡೋದೇ ಆದ್ರಿಂದ ಕೋಆಗುಲೇಟಿವ್ ಪವರ್. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? ಇದು ಜಾಸ್ತಿ ಆದಷ್ಟು, ಕೋಆಗುಲೇಟಿವ್ ಪವರ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಅರ್ಥ ಏನು? ಬೇಗನೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ. ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್, ಕೋಆಗುಲೇಟಿವ್ ಪವರ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ? ಬೇಗನೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ. ಆದ್ರೆ ಕೋಆಗುಲೇಟಿವ್ ಪವರ್ ಜಾಸ್ತಿ ಆದಷ್ಟು ಆ ಒಂದು ಅಯಾನಿನ ಕೋಆಗುಲೇಟಿವ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗಿರುತ್ತೆ? ಅತಿ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಸೊ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ವಾ? ಅರ್ಥ ನಮಗೆ ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಿ, ಅವಾಗ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಕಟ್ ಆಗಿ ನಾಲೆಜ್ ಗೊತ್ತಾಗುತ್ತೆ. ಬಟ್ ಡೂ ರಿಮೆಂಬರ್, ಯೋರ್ ಕೋಆಗುಲೇಟಿವ್ ಪವರ್ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ ಕೋಆಗುಲೇಟಿವ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಯೋರ್ ಕೋಆಗುಲೇಟಿವ್ ಪವರ್ ಅಲ್ವಾ? ಹೈಯರ್ ದಿ ಕೋಆಗುಲೇಟಿವ್ ಪವರ್, lower will be the coagulative value. Yes. So now let's have a quick revision of what we have done today. So basically, whenever we are doing a precipitation of your colloids, of course in that one method we saw it was by the addition of electrolytes. But there one question arises within us that, okay, if in case if you have been given with some specific charged colloidal particles and you have been given with 4 to 5 electrolytes, yeah, which is having a different charges. Now the question arises that which electrolyte will be required in a minimum concentration, in order to coagulate the overall colloidal system. Alva yake minimum concentration hai? Remember, whenever in science we are doing, of course we will be using a minimum chemicals in order to extract a maximum yield. That is our economical mind. The same tendency over here. ಸ್ವಲ್ಪ ಹಾಕಿದ್ರೆ ಸಾಕು ಒಂದು ಸಾಲ್ಟ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನ ಏನಾಗಬೇಕು ನಮಗೆ ಬೇಗನೆ ನಮ್ಮ ಸಿಸ್ಟಮ್ ಕೊಲಾಯ್ಡ್ ಆಗಿದೆ ಏನು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರುತ್ತೆ ಬೇಗನೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗಬೇಕು. ದಟ್ ಇಸ್ ದಿ ಕಾಮನ್ ಕ್ರೈಟೀರಿಯಾ. ದಟ್ ಇಸ್ ದ ರೀಸನ್. So in case I have given you an example that in case if you are having a AlCl3, BaCl2 and NaCl and you have been given with that of your negatively charged salt, the question is that which among the 3 electrolytes will be required in a minimum quantity. So in order to answer this, 2 scientists came forward, Hardy and Schulze, and they gave us a rule which is itself is called as what? Hardy-Schulze Rule. What is that? According to which it says that greater the valence of the fluctuating ion, alva. Fluctuating ion means nothing, which causes the precipitation, which causes a flocculation, okay, which causes a coagulation. All the 3 words are same. So greater the valence of the fluctuating ion added, yes, greater, very much important. Greater the valence of the fluctuating ion added, what happens? Greater will be the power to cause the precipitation. Alva. Greater the valence of the fluctuating ion added, greater will be its power to cause your precipitation. That is the common rule of your Hardy-Schulze rule. Very much important. What does it mean actually? In case if I have given you a negatively charged colloidal salt, okay, what I have given you a negatively charged colloidal salt, and you have been given with the 3 electrolytes, that is your aluminium chloride, barium chloride and sodium chloride. Of course we know what, in case we have to precipitate your negatively charged colloidal particle, what the ion we would be requiring? Positively charged ion. So in order to Hardy-Schulze rule, what does it says? So greater will be the valence of your fluctuating ion, greater will be its power to cause the precipitation. So in that case, what we have to check out, what will be the valence of your respective ions, alva? Illi navu yavadu nodti positive ions. Yake? Because a given salt is a negatively charged salt. So al nodidaga we are getting as what? Al is having a +3 valence, Ba is having a +2 valence, Na is having a just +1 valence. So among these 3, which is having the higher valence, it is your Al +3. So that is, it will be required in a smaller quantity. Hagare artha enu? AlCl3 will be required in a smaller quantity in order to flocculate your colloidal particles. Alva? Yake anta kelidaga basically 1 Al ion, Al+3 ion will be equivalent to that of your 3 charged colloidal particles of oppositely charged. Alva? Jasti charge ಆದಷ್ಟು ಅತಿ ಬೇಗ ಏನಾಗುತ್ತೆ colloidal particles ಅಂತ ಕಡೆ ಹೇಳ್ಕೊಂಡು maximum ನಿಮಗೆ coagulation ಆಗುತ್ತೆ. The same thing, in case if you have been given with a positively charged salt, the same scenario repeats. But here what we have to choose, since the given colloidal salt is a positively charged, our fluctuating ion will be negatively charged, alva, oppositely charged. Illi kuda higher the valence of your negatively charged colloidal salt, greater will be its power to cause the coagulation. So this is the most important. In both the cases, what we have to see, the highest number for your valence. Plus and minus is indicating its respective charges. Don't go with that part. You have to just see the numbers. Negatively charged salt kotre namage positive ಅಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ನಂಬರ್ ಉಂಟು ಅಂತ ನೋಡಬೇಕು. Positively charged salt is given, negative ಅಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ನಂಬರ್ ಉಂಟು ಅಂತ we have to see. Is that okay? But do remember, whenever we are writing, we are measuring it with respect to that of your coagulative power. Why? Because if the coagulative power is more, precipitation rate will be also more. That is, to cause the precipitation, it will be at a higher rate. We will be obtaining our precipitate at a faster rate. So coagulative power is a direct measure of your precipitation. So that is the reason whatever we will be writing, it is with respect to that of your coagulative power. But it is not so easy to calculate your coagulative power. Instead of that, what we do, we calculate your coagulative value. What does your coagulative value says? It is actually the minimum concentration of an electrolyte in millimoles per liter required to cause the precipitation of a salt in 2 hours. What is the minimum concentration of the electrolyte required to cause the coagulation in just 2 hours? It's called as what? Coagulative value. But when we were seeing with the Hardy-Schulze rule, we saw whatever the measurement we are doing with respect to the valence of the ions, it was with respect to the coagulative power. But whatever we are measuring is a coagulative value. So it was a tendency to relate how these two are related, coagulative value and coagulative power. So we saw that coagulative value is inversely proportional to that of your coagulative power. Higher the coagulative power, that is a fluctuating ion in a power to cause the precipitation ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನು ಅದರ ವ್ಯಾಲ್ಯೂ ಏನು ಸಿಗ್ತಿರುತ್ತಲ್ಲ ಅದು ಅತಿ ಕಮ್ಮಿ ಇರುತ್ತೆ. Once again I am repeating, coagulative power means what? Actually it is the power of your fluctuating ion to cause the precipitation, alva? So greater the power of your fluctuating ion, what will be the value of its coagulative value? Very least. Able to understand? So higher the coagulative power, lower will be your coagulative value. So better understanding will be done when we are seeing certain questions and we are going to solve it. So now let us go with our first question over here. So basically the given question is in this way. The coagulation values, please do remember, whenever you are seeing certain questions, you have to see whether they have given you the coagulative power or a coagulative value. So what they have given over here, the coagulation value they have given in millimoles per liter of the electrolytes used for the coagulation of your arsenic sulfide. Alva? So arsenic sulfide, and we know the sulfides will be what? Sulfide salts will be negatively charged salt. That is the common thing, we know that. So now what we have to see, so whatever the electrolytes they have given to us and they have measured their coagulative values. And they have said to us to coagulate your negatively charged salt, that is your arsenic sulfide. So they have given overall NaCl coagulative value is 52. Able to understand? Coagulative value, this is the minimum concentration. 52 millimoles per liter of NaCl is required to coagulate your arsenic sulfide in 2 hours. Alva? Coagulative value pragar definition ಗೆ ಹೋದಾಗ. ಅದೇ ರೀತಿ if you are choosing your barium chloride, see, it is just 0.69. That means what? It is the minimum concentration. 0.69 millimoles per liter is required to coagulate your arsenic sulfide in 2 hours. Coming with respect to magnesium sulfide, what it is giving? 0.22. Able to see? Which means what? It is the minimum concentration of your electrolyte required to cause the coagulation of your arsenic sulfide in 2 hours. Now you are getting the relationship. Why coagulative power is inversely proportional to coagulative value? Ille nodಬಹುದು. ಅದೇ ಆರ್ಸೆನಿಕ್ ಸಲ್ಫೈಡ್ ನಾನೆಲ್ಲಾದ್ರೂ NaCl ಜೊತೆ coagulate ಮಾಡಬೇಕು ಅಂದಾಗ how much NaCl concentration I should maintain? 52 millimoles per liter. Do remember. The same arsenic sulfide has to be coagulated by using your barium chloride. What is the minimum concentration is required? Just 0.69. The same amount of arsenic sulfide has to be coagulated by using your magnesium sulfide. What is the minimum concentration required? Just 0.22. Now let us see the question. What is the correct order of their coagulation power is? What is the correct order of their coagulation power they have given? Very much important. So here they have given us the values. Whereas in the answer they have asked us to arrange it in the order, in the increasing or decreasing in the correct order of your coagulation power. So what we know, of course, your coagulation value is inversely proportional to coagulative power. So among the three, which one is having the least coagulative power? Of course, your magnesium sulfate, 0.22. So least coagulative value is for your magnesium sulfate, which is 0.22. So it will be having the highest coagulative power. So that should come first. Where we are seeing it? Yes, in the option C. What we are seeing? See, third is having the highest, alva. Third is having the highest. Then they have given the second, alva. Soon after MgSO4, the next least value of your coagulative value is 0.69, which will be highest. Soon after your magnesium sulfide, so it will be your barium chloride. And then it is your 1. So the correct answer or the correct option for this is C. Able to understand? This question is because in order to get a clear-cut knowledge of what do you mean by coagulative value. So what do you mean by coagulative value? NaCl is having a coagulative value of 52 means what? 52 millimoles per liter of the NaCl is required to coagulate your arsenic sulfide. Similarly, 0.69 coagulative value of BaCl2 means what? 0.69 millimoles per liter of your electrolyte is required to coagulate your arsenic sulfide. Similarly, magnesium sulfide means what? 0.22 is the minimum. That is itself is the minimum. 0.22 is required, millimoles per liter is required to coagulate your arsenic sulfide. Here itself we are getting the knowledge why your coagulative power is inversely proportional to that of your coagulative value. So coagulative value ಕಮ್ಮಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ ಸ್ವಲ್ಪ ಅಮೌಂಟ್ ಸಾಕು in order to increase the rate of precipitation. ಆದ್ರೆ ಸ್ವಲ್ಪ ಇದ್ದಷ್ಟು ಏನಾಗ್ತಾ ಉಂಟು ಪ್ರೆಸಿಪಿಟೇಷನ್ ರೇಟ್ ಜಾಸ್ತಿ. ಆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ರೇಟ್ ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಮೆಷರ್ ಮಾಡ್ತಾ ಇರೋದು ಯಾವುದು? ಕೋಆಗುಲೇಷನ್ ಪವರ್ ಅಲ್ವಾ? ಸೊ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ಆದಷ್ಟು ಕೋಆಗುಲೇಷನ್ ಪವರ್ ಏನಾಗುತ್ತೆ ಅಥವಾ ನಿಮ್ಮ ಪ್ರೆಸಿಪಿಟೇಷನ್ ರೇಟ್ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಕಮ್ಮಿ ಆದಷ್ಟು precipitation power is growing at a faster rate. So that is the reason your coagulative value is inversely proportional to that of your coagulative power. Is that clear? So now let us see certain other examples over here. So basically here they are given was what? The electrolyte having the maximum fluctuating value. Please do remember, the electrolyte having the maximum fluctuating value. So here I have to mention, I have to find out the fluctuating value. So when I have used my Hardy-Schulze rule, do remember whatever I have written that Al plus 3 is greater than Ba plus 2, that is greater than Na plus, that was with respect to what? Coagulative power. Highest coagulative power was which one? Al plus 3. ಹಾಗಾದ್ರೆ Al plus the coagulative value ಏನಾಗಿರುತ್ತೆ? It will be the very least when compared to your barium and sodium. Similar scenario, but here what I am going to write, I have to mention what? Maximum fluctuating value. So maximum fluctuating value ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Minimum fluctuating power ಅಲ್ವಾ? Least fluctuating power ನ ನಾನೀಗ ಕಂಡುಹಿಡ್ಕೋಬೇಕು. ಹಾಗಾದ್ರೆ ಈ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ನಂಗೆ ಫಸ್ಟ್ ಸಾಲಿನ ಚಾರ್ಜ್ ಬೇಕಲ್ವಾ? So what is the charge of the sol? Let us see. So here they are given as AgI bar Ag plus. So fixed layer alli nange ಏನು ಉಂಟು? Ag plus ಉಂಟು. So it is giving a hint that whatever the colloidal particle we are having, it is a positively charged sol. Okay. One important criteria we have got that it's a positively charged sol. So in order to coagulate it, we require a negatively charged electrolyte. Okay. Second hint. But what is the question? We want to find the electrolyte having the maximum fluctuating value. Maximum fluctuating value andre which is having the least fluctuating power. Okay, least fluctuating power andre artha enu? Hardy-Schulze prakara greater the valency, greater will be the fluctuating power. So now I have to find out what? Lesser the valence. Least valence I have to find. So least valence, least will be the fluctuating power, maximum will be the fluctuating value. So here of course it is a positively charged, so in the Na2 plus, how can I write it? Na2 plus means I will be having as Na plus and that of your S2 minus, alva 2Na plus and S2 minus. So this is my negatively charged electrolyte, S2 minus. Whereas here I am getting as what? Na plus and a Cl minus. Okay. Coming over here, here I will be getting as what? 3Na plus plus that of your PO4 3 minus. Yes. Coming to that of your sodium sulfate, I will be having as 2Na plus plus SO4 2 minus. Alva. Remember, once again I am making sure I have been asked for a maximum fluctuating value. So I have to find an ion which is having the least fluctuating power. Least. So least fluctuating power will be for which one according to Hardy-Schulze rule? For the least valence of your respective electrolyte. So among the given electrolytes, of course the least values for which one? Here it is -2, which is also highest when coming to that of your phosphate, which is -3. Here also -2. Least here the Cl -1. So ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? It will be the option C. ಅಲ್ವಾ? ಯಾಕೆ C? Because it will be having the least fluctuating power. Why least fluctuating power? Because it is having the least ion or the least valence. Least valence, least will be the fluctuating power. So since it is inversely proportional to fluctuating value, it will be having the maximum fluctuating value. So whenever you are seeing the question, you should be very much accurate whether they have asked you or given you the fluctuating value or the fluctuating power. Okay. Now let us come to the second part. Here basically you have been given with a maximum, the maximum precipitating power. Alva. So power anta bandkule nimma mind ಗೆ ನಿಮಗೆ ಫ್ಲಾಶ್ ಆಗ್ಬಿಡ್ಬೇಕು. Okay, it is directly related to that of your precipitation. Power ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ? ನಿಮಗೆ ಆದಷ್ಟು ಬೇಗ ನಿಮ್ಮ precipitation ಆಗ್ಬಿಡುತ್ತೆ. Okay. So ಏನ್ ಹೇಳುತ್ತೆ? The maximum precipitating power for negatively charged salt, arsenic sulfide, will be exhibited by which of these electrolytes? So first important criteria, which charge we have to choose. Whether we have to choose negative or a positive charge. So since it is a negatively charged salt, our electrolyte should be positively charged. Coming with respect to what they have given, the maximum precipitating power. Precipitating power should be maximum and the artha enu? Higher should be the valence of your positively charged electrolyte. Alva. So ilig barana. So here you will be getting as what? 2 times of your K plus barutte. Whereas in CaCl2, here you are having a Ca2 plus. Na3PO4 bandre 3Na plus. AlCl3 bandre, it is your Al plus 3. Now you can please help me out. So which will be having the maximum precipitating power? It is for your AlCl3. Why? Higher the valence of your fluctuating ion, higher will be its tendency to cause the flocculation or precipitation. So here also they have asked, ಯಾವುದಕ್ಕೆ maximum precipitating power ಉಂಟು? ಯಾವುದು ಅಯಾನಿಗೆ ತುಂಬಾನೇ ಅತಿ ಹೆಚ್ಚು ವೇಲೆನ್ಸ್ ಇರುತ್ತೋ ಅದಕ್ಕೇನೆ ಫ್ಲಕ್ಯುಲೇಟಿಂಗ್ ಪವರ್ ಕೂಡ ಜಾಸ್ತಿ ಇರುತ್ತೆ. Is that clear? Coming to the next question, what is this saying? The amount of electrolytes required to coagulate a given amount of AgI colloidal solution. So AgI avare kottidare, it is negative charge. Okay, I have got a hint that my electrolyte will be positively charged. Yes, will be in the order. So ಯಾವ ಆರ್ಡರ್ ಅಲ್ಲಿ ನನ್ನ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ರಿಕ್ವೈರ್ಡ್ ಆಗಿರುತ್ತೆ ಅಂತ ನೋಡ್ಬೇಕು ನಾನು. ಇಲ್ಲಿ ನಮ್ಗೆ ಯಾವ್ದು ಕೋಯಾಗುಲೇಟಿವ್ ಪವರ್ ಕೊಟ್ಟಿಲ್ಲ, ಕೋಯಾಗುಲೇಟಿವ್ ವ್ಯಾಲ್ಯೂನು ಕೊಟ್ಟಿಲ್ಲ. ಸೊ ನನ್ನ ಮೈಂಡಿಗೆ ನಾನು ಬಂದ್ಬಿಡ್ಬೇಕು ಏನಂತ, ಯಾವ್ದಕ್ಕೆ ಅತಿ ಹೆಚ್ಚು ವೇಲೆನ್ಸ್ ಇರುತ್ತೋ, ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ವೇಲೆನ್ಸ್ ಇರುತ್ತೋ ಅದು ಫ್ಲಕ್ಯುಲೇಟಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಹಂಗಾದ್ರೆ ಅರ್ಥ ಏನು? ಬೇಗನೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಯಾವ ಅಯಾನ್ ನೋಡ್ಬೇಕು ನಾನು? ಪಾಸಿಟಿವ್ ಅಥವಾ ನೆಗೆಟಿವ್? ಅಫ್ಕೋರ್ಸ್ ಕೊಟ್ಟಿರೋ ಸಾಲ್ ಏನಾಗಿದೆ, the given colloidal solution is having a negative charge. So I should choose an electrolyte which is a positively charged. So I should check the valence of my positively charged electrolytes. Okay. Coming over here. Here I am having just what? +1. Of course it cannot be first notes kula gottagide idಕ್ಕೆ highest ಇರಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಯಾಕಂದ್ರೆ valence ಕಮ್ಮಿ ಉಂಟು. Okay, rejected. Coming to over here. Okay, here it is having Al +3. Yes. And coming over here, it is having Ba +2. Yes. Coming over here, Na +1. Okay. So we can have a 2 option over here. So coming over here, Al +3 +1 +2. alva. Oh no, not possible. Coming over here you are having as what? Na plus 1, Ba plus 2, Al plus 3. So which will be your option? If you're thinking your option is B, of course it is wrong. Why wrong? ಇಲ್ಲಿ ಏನು ಕೇಳಿದ್ದಾರೆ ಕ್ವಶನ್? ದೇ ಹ್ಯಾವ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ ದಿ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಲ್ವಾ? ಸೊ ದೇ ಹ್ಯಾವ್ ಆಸ್ಕ್ಡ್ ಫಾರ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ರಿಕ್ವೈರ್ಡ್, ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ರಿಕ್ವೈರ್ಡ್ ಟು coagulate your given amount of AgI. ಯಾವ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನಮಗೆ ಸ್ವಲ್ಪನೇ ಸಾಕು ಇನ್ ಆರ್ಡರ್ ಟು ಕಾಸ್ ಮೈ coagulation. ಅಫ್ಕೋರ್ಸ್ ನಾನು ಇಷ್ಟಂಗ ಏನ್ ನೋಡಿದೆ? ಚಾರ್ಜ್ ನೋಡಿದೆ. ನಮ್ಗೆ ಎಲ್ಲಿ ಏನ್ ಗೊತ್ತಾಯ್ತು? +3 ಚಾರ್ಜ್ ಇದ್ದಷ್ಟು ಏನಾಗುತ್ತೆ, ನಮ್ಗೆ ಬೇಗನೆ coagulate ಮಾಡುತ್ತೆ. ಸ್ವಲ್ಪ ಅಮೌಂಟ್ ಸಾಕಲ್ವಾ? 1 Al plus 3 ಇದ್ರೆ ಇಟ್ ಕ್ಯಾನ್ coagulate 3 oppositely charged colloidal salt. ಸೊ ಹಾಗಾದ್ರೆ Al will be required in a smaller quantity. Soon after Al, which will be required? Your Ba plus 2, which will be required in a smaller quantity. Highest quantity ಯಾವ್ದು ಬೇಕಾಗುತ್ತೆ? Your NaNO3, because it is having the +1. So see your question. They have asked for the amount of the electrolyte required. Higher the charge or higher the valence, what happens? Higher will be the flocculating power. It can cause the coagulation at a faster rate, and also it will be required in a minimum quantity. ಅಲ್ವಾ? ಸೊ ಆ ರೀಸನ್ ಇಂದ ಅತಿ ಕಮ್ಮಿ ಬೇಕಿರೋದು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಯಾವ್ದು ನಂಗೆ? Al plus 3. ಓಕೆ, ಇಟ್ ಈಸ್ ದಿ ಲೀಸ್ಟ್ ಪಾರ್ಟ್. ಅದಾದ್ಮೇಲೆ ಸಿಗೋದು ಯಾವ್ದು ನಂಗೆ? BaNO3. ಅಟ್ ಲಾಸ್ಟ್ ಯುವರ್ NaNO3, ವಿಚ್ ಇಸ್ ದಿ ಹೈಯೆಸ್ಟ್. ಸೊ ಇದನ್ನ ಮೆಷರ್ ಮಾಡ್ತಾ ಇರೋದು ನಂಗೆ ಡಿ ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ವಿಚ್ ಅಲ್ಯೂಮಿನಿಯಂ ವಿಲ್ ಬಿ ರಿಕ್ವೈರ್ಡ್ ಅಟ್ ದಿ ಲೀಸ್ಟ್ ಪಾರ್ಟ್, whereas sodium nitrate will be required at the highest part. So see your questions. Questions are very much important. Coming to the next question. Which one of the following acts as the best coagulating agent? This is my question. Which of the following electrolytes will be acting as what? Best coagulating agent in order to coagulate what? Ferric hydroxide salt. So we know what ferric hydroxide is. Which type of a salt? It is a Yes, hydrated metal oxides. So it is what we can say a positively charged salt. So what we have to measure now? We have to check out the valence of your negatively charged electrolytes. Alva? So ferric hydroxide salt anta bandaga illi nodi magnesium chloride, which is having what? Cl minus, aluminum chloride Cl minus, hydrochloric acid Cl minus. Yes. Coming over here, potassium oxalate, C2O4 2 minus. Okay, potassium ferricyanide K plus, potassium ferricyanide, ಅದಕ್ಕೆ ನೋಡಿ complex is coming over. Potassium ferricyanide ಯಾವ ತರ ಬರೀಬಹುದು ನಾವು? K3 FeCN6. Why I choose as K3? Because ferricyanide ಬರಬೇಕು. ಹಂಗಾರೆ ferricyanide ಅಂದ್ರೆ ಅರ್ಥ ಏನು? Fe ನ ನಾನು ಓವರ್ ಆಲ್ ತಗೊಂಡಾಗ +3 ಚಾರ್ಜ್ ಬರಬೇಕು. ಸೊ ಹಾಗಾದ್ರೆ ಆನಯಾನಿಕ್ ಪಾರ್ಟ್ ಏನಾಗಿರುತ್ತೆ? FeCN6 3 ಮೈನಸ್ ಅಲ್ವಾ? ಸೊ ಈಗ ನಮ್ಮ ಕ್ವಶನ್ ಓದ್ಕೊಳ್ಳೋಣ ಇನ್ನೊಂದ್ಸರಿ. ಏನ್ ಹೇಳಿದ್ದಾರೆ? ವಿಚ್ ಆಫ್ ದಿ ಫಾಲೋಯಿಂಗ್ ಆಕ್ಟ್ಸ್ ಅ ಬೆಸ್ಟ್ coagulating agent. ಸೊ ಬೆಸ್ಟ್ coagulating agent ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದಿ ಹೈಯೆಸ್ಟ್ coagulative ಪವರ್. ಸೊ ಹೈಯೆಸ್ಟ್ coagulative ಪವರ್ ಇಸ್ ಡೈರೆಕ್ಟ್ ಮೆಜರ್ ಆಫ್ ಯೋರ್ ಹೈಯರ್ ವೇಲೆನ್ಸ್. ಸೊ ಯಾವ್ದಕ್ಕೆ ಇದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ವೇಲೆನ್ಸ್ ಇರೋದು? ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್ ನ ಯಾಕೆ ಚೂಸ್ ಮಾಡಿದೆ? ಬಿಕಾಸ್ ವಾಟ್ ಎವರ್ ಯುವರ್ ಫೆರಿಕ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಸಾಲ್ಟ್ ಇಸ್ ದೇರ್, ಇಟ್ ಇಸ್ ಅ ಹೈಡ್ರೇಟೆಡ್ ಮೆಟಾಲಿಕ್ ಆಕ್ಸೈಡ್ ಸಾಲ್ಟ್ ಅಲ್ವಾ? ಸೊ ಮೆಟಾಲಿಕ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ? ಇಟ್ ಇಸ್ ವಿಲ್ ಬಿ ಕಾಮನ್ಲಿ ಇಟ್ ವಿಲ್ ಬಿ ಕಮಿಂಗ್ ಅಂಡರ್ ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ ಸಾಲ್ಟ್. ಸೊ ಆ ರೀಸನ್ ಇಂದ ನಮ್ಮ ಚೂಸನ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನಾವು ಏನ್ ನೋಡಬೇಕು? ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ನ ನೋಡಬೇಕು. ಸೊ ಇದ್ರಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಯಾವ್ದು ಜಾಸ್ತಿ ಇರೋದು? ಪೊಟ್ಯಾಷಿಯಂ ಫೆರಿಸೈನೈಡ್. ಸೊ ಆಪ್ಷನ್ ವಿಲ್ ಬಿ ಯೋರ್ ಇ. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಸೊ ರಿಮೆಂಬರ್, very much important, once again I am repeating, coagulative value tagondre, coagulative value, it is always inversely proportional to that of your coagulative power. Coagulative power. So according to Hardy-Schulze rule, whatever we saw, it was with respect to that of your coagulative power. Higher the coagulative power, greater will be the rate to cause its precipitation. Minimum will be its concentration required. Coagulative power ಜಾಸ್ತಿ ಉಂಟು ಅಂದಾಗ ಏನಾಗುತ್ತೆ? coagulative value ಕಮ್ಮಿ ಆಗ್ಬಿಡುತ್ತೆ. ಆರ್ ಇನ್ ಸಿಂಪಲ್ ವರ್ಡ್ಸ್ ಕೋಆಗುಲೇಟಿವ್ ವ್ಯಾಲ್ಯೂ ಕಮ್ಮಿ ఉంటుంది ಅರ್ಥ ಏನು ಯಾವುದೋ ಒಂದು ಅಯಾನಿಗೆ ಅದು ಟೆಂಡೆನ್ಸಿ ಟು ಕಾಸ್ ದಿ ಪ್ರೆಸಿಪಿಟೇಷನ್ ವಿಲ್ ಬಿ more. That is the common thing. So very much important concept. You have to remember whenever you are seeing the question, you have to see first whether they have given you the coagulative value or the coagulative power. Coagulative power ಕೊಟ್ಟಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Coagulative power ಜಾಸ್ತಿ ಆದಷ್ಟು ಏನಾಗುತ್ತೆ, ಬೇಗನೆ ನಿಮಗೆ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಸಿಗುತ್ತೆ, ಅಮೌಂಟ್ ಕೂಡ ಕಮ್ಮಿ ರಿಕ್ವೈರ್ಡ್ ಆಗಿರುತ್ತೆ. ಆದ್ರೆ coagulative value ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ you have to recall the concept that it is inversely proportional to coagulative power. So my hint is to you is that basically you try always to relate your coagulative power itself. Coagulative power ಸಿಕ್ಕಿದ ಕೂಡ ನಿಮಗೆ ಒಂದು ಐಡಿಯಾ ಸಿಕ್ಬಿಡುತ್ತೆ. It will just make your brain to bright. Okay, coagulative power is ಜಾಸ್ತಿ ಇದ್ದಷ್ಟು ಬೇಗನೆ coagulation ಆಗ್ಬಿಡುತ್ತೆ. So coagulative value ಕೊಟ್ಟರು ಕೂಡ try to relate it with coagulative power. So easily you can solve certain your competitive exams problems easy way. Okay, yes.